All right, my friend. So once again, I'm going to talk a little bit more solving linear inequalities. And what we're going to talk about today is the other compound linear inequality and compound linear inequalities. All right, and what you're going to see, there's going to be a lot of commonalities with what we did yesterday when we talked about our OR compound linear inequalities. All right, so you can see this is standard 14.3. I can solve and compound linear inequalities. All right, and just like we did before, I'm going to get you started with just solving two independent linear inequalities. So right now, if you would solve part A and part B, all right, go ahead and pause the video, solve both of those linear inequalities, turn it back on, and we'll see how you did. All right, so let's take a look at the work for both of those. So once again, all right, we want to solve for the anchor first. All right, so we just set up our equation, and we solve like normal, and so we get that our anchor is -6. We know that anchor is going to get an open circle because we have less than here. And then once again, we have to test. All right, see which side to shade on. And when I test 0, all right, I get -37 is less than -1, which is a true statement. So I want all the numbers here on the right side. So that would be x is greater than -6. All right, looking at part B here. So once again, we want to solve for our anchor first. So when we solve that equation, we get x equals 1. All right, this time our anchor is going to get a solid circle because we have that less than or equal to. All right, so we get that solid circle here. And when I test to see where I shade again, once again, I plug in 0. All right, I get -1 is less than or equal to 5. So once again, that means 0 is on the true side here. So this is the true side, which means that's the false side. So we want to shade, all right, to the left. All right, I should have labeled the true and false side over here. All right, and then once again, when I want the numbers left of 1, those are all the numbers that are less than 1. So my inequality here would be x is less than or equal to 1. All right, so once again, just two independent problems here, right? And so like we talked about in the last video when we did OR compound inequalities, all we're going to do today is once again, we're going to take those and put them together. Now, mathematically, all right, and means something a little bit different than OR, and I'm going to talk about that as we look at the results here. So notice if I just take our work from above, right? So if we take that x is greater than -6, and I put it on this number line, and I shade to the right like this, okay? And I take x is less than or equal to 1, and I put that on my number line, and I shade, and I get this. Notice the difference between yesterday and today, all right? Between our prior lesson and today's lesson, all right? We get where the solution sets cross over, all right? Now, that's important because in math, and means both things have to be true. Okay, now this is really very similar to what we did when we graphed our linear inequalities, and we talked about the overlap, correct? All right, and that overlap was the true solution to our system of linear inequalities. And that's really what's happening with an and. All right, so when we say and, all right, okay, we need both things to be true mathematically. Well, where are both things true? Both things are true where they overlap, okay? So notice the difference between OR and AND. Okay, with OR, I could have one thing or the other. It doesn't matter which one as long as I get one part or the other, and I'm good. All right? Hey, go to McDonald's, give me a Big Mac or a quarter pounder with cheese. As long as you bring me back one or the other, I'm good. I'm happy. All right? Hey, go to McDonald's. All right, I want a Big Mac and fries. Okay? So if you bring me back just a Big Mac, I'm not happy. If you bring back just the fries, I'm not happy because I wanted a Big Mac and fries. All right, so the same thing is true mathematically. So when we say and, we need both things to be true. All right, and so mathematically, the way that's represented on our number line, it's that region where both inequalities cross. All right, so then our inequality, notice, looks a little bit different. All right, so we call this a compacted, all right, inequality because it's written all as one. And if you can see, it models what's happening here, right? So here's -6. Right? Here's 1, and we want all the x values between. All right? And so those values are less, all right, than or equal to 1, and they're greater than -6. All right? So it looks a little different, but that also gives us a very big hint that it's an and compound inequality. All right. So what does that look like, right? So notice yesterday when we did an OR, it would just be this or that. Now, we can put the and in here, but this is traditionally not what you typically see mathematically. What you're going to see is the compacted version where they write it like this. all right, we still have two inequalities. So there's my first inequality is if I cover up the right side. So you can see that's the one that's right there, correct? All right. If I cover up the left side here, you can see that there's my second inequality. So I have two inequalities just like we did yesterday, all right, but now they're kind of squished together, all right, and just written a little differently. But like I said, this right here is a dead giveaway that you have an and compound inequality because this is the only time we see this, all right, when we're working with our inequalities. All right, so how do we work with these, right? So if it's written in compacted form, all right, what we're going to do is break them into two separate problems, all right? So we're going to take this and write it like this, all right? And then we just basically go through the same process, right? We're going to solve for our anchors. We're going to mark our anchors with a closed or open circle based on our inequality symbol. We're going to test, all right? And then we're going to write the inequality that's represented on the number line. And then just remember with and, we're going to get this look when we write our inequality, okay? Now, before I move on, if for some reason we don't get the crossover region, that means it's no solution, all right? So we have to have the regions cross, okay? All right, so let's look at the next page here. And let's start, once again, by just writing some inequalities, all right, from a number line, just to familiarize you with how to do that, okay? So now, when I look at this, once again, we see we have that shaded region in the middle. That's that crossover region, all right? So notice, all right, I have -10, and then I have -3, and I want all the values between -10 and -3. Well, when I go to the right, that means x has to be greater than -10, and if I go to the left, -3, x has to be less than -3, okay? And if you write it in this way, your symbols will always kind of point to the left, all right, because the number in the middle is always going to be greater than the left-hand endpoint and less than the right-hand endpoint. All right, so let's move to number 2. Let's move to number 2. So once again, -8 is our left-hand endpoint. All right, -1 is our right-hand endpoint, and we want those numbers in the middle. All right, and so they're going to be x is greater than -8 and x is less than -1. All right, and just like with our or compound inequalities, right, we could have a mix of anchors, whether they're closed or open. So once again here, this is -3 is our left hand, 7 is our right hand. We want all the numbers in the middle. And so this time x is going to be greater than or equal to -3, but x is less than 7. And then for number 4, right, 5 is our left hand, 8 is our right hand. We want all the values in the middle. All right, and so x is this time is going to be greater than or equal to 5 because we have that solid circle, or less, or excuse me, and less than or equal to 8 because we have that closed circle there. All right, so hopefully that helps you with writing those inequalities. Okay, so now let's go to, like, now we have to solve to get to this point, right? So let's talk about how we're going to do that. So now, all right, look at our problem in number 6. And this is what I mean by the compacted writing. Okay, so you can see that we know there's two inequalities because we can see the two symbols here. So that implies that we have two different problems. All right, and so like I said, what we're going to do is we're just going to cover up the right inequality symbol like that, and that's our first problem that we want to solve. All right, so the first thing we want to work on is -69 is less than 1 minus 10x. So that's our first problem. All right, and now what I'm going to do is cover up the opposite side here. I'm going to cover up that opposite inequality, and 1 minus 10x is less than or equal to -59. So we're just going to break those into two pieces before we start, all right, and then we'll go from there, okay? And now it's really set up just like what we did yesterday when we worked our OR problems. So I want to solve for my anchor first, so I'm going to make this an equation. So -69 equals 1 minus 10x. All right, I'm going to get it equal to 0, so I'm going to add 69 to both sides here. So 0 equals 70 minus 10x. All right, so 70 minus what is 0? 70 minus 70 is 0. So that means 10x has to equal to 70, which means x has to equal to 7. All right, so there's our first anchor. We know it's going to be an open circle and anchor because we have a less than symbol up there, so there's that. All right, and then now, just like we've done before, we want to test to see which way we shade. So I'm going to test 0, which is on the left side here. All right, so we have -69 is less than 1 times 1 minus 10 times 0. All right, 10 times 0 is 0, so I get negative 69 is less than 1, and that's a true statement. So I want to shade to the left. All right, so 0 is on the left, it's true, so I want to shade to the left. Okay, all right, so now we just come over, and now we're going to work problem number 2. All right, so 1 minus 10x equals negative 59. All right, add 59 to both sides to get it equal to 0. So 60 minus 10x is equal to 0. All right, so once again, 60 minus what is 0? 60 minus 60 is 0. So that means 10x has to equal to 60. 10 times what is 60? And that would be 6. So there's our second anchor. All right, and we know it's going to have a solid dot because we have a less than or equal to up here. So we're going to get a solid dot on our anchor there. And then once again, let's test 0 and see what result we get. So I'm going to have 1 minus 10 times 0 is less than or equal to negative 59. So 10 times 0 is 0, so I'm left with 1 is less than or equal to negative 59. And that is a false statement. So 0 is to the left. So everything to the left of 6 is false, which means I want to shade to the right. And there we go. So now we see that we get that crossover, correct? All right, and that crossover, right, that's where, all right, our solution set is, because it's an and. We have to have both things be true. So notice 6 is our left-hand endpoint. 7 is our right-hand endpoint. We want all the numbers in between. And then this is going to be x is greater than or equal to 6. And then x is less than 7. Just like that. All right, so you can see it's really very, very similar to what we've done before, right? But it's a little bit more work at the beginning to break our inequality into our two problems. All right, so let's take a look at number 6 here, okay? All right, looking at number 6, once again, we can see the compacted version here. We can see the two inequality symbols. So what we're going to do is just cover up the right side, okay? So here is our first inequality that we need to solve. So we need to solve negative 4x minus 28 is less than 6x minus 8. Okay, and then we need to solve the other one. So if I come over here and cover up the other side here, all right, and 6x minus 8 is less than x minus 3. So those are the two guys that we need to solve, all right? Okay, so now once again, we just go through our normal process, right? So we want to solve for those anchors first. So negative 4x minus 28 is equal to 6x minus 8. All right, we want to get one side equal to 0, so I'm going to subtract 6x and subtract 6x. I'm going to add 8 and add 8. So I get negative 10x minus 20 is equal to 0. All right, so once again, what minus 20 is 0? 20 minus 20 is 0. All right, so that means negative 10x is equal to 20. And then negative 10 times what is 20? And that would be negative 2. So there's our first anchor. We know this anchor is going to have an open circle because we have a less than symbol up here. So I'm going to go to negative 2 and I'm going to put my circle on that just like so. And now once again we want to test, all right, and see which way we shade. So I'm going to have negative 4 times 0 minus 28 is less than 6 times 0 minus 8. All right, so negative 4 times 0 is 0, so I get negative 28 is less than, and then 6 times 0 is 0, and I get negative 8. All right, so that is a true statement. Negative 28 is less than negative 8, so 0, 0, which is on the right side, is the true side. So we're going to shade to the right, just like that. All right? All right, so now let's solve for our second anchor. So 6x minus 8 is equal to x minus 3. All right, and I'll just draw a little line here to kind of separate here. So I'm going to subtract x, add 3 to get this equal to 0. All right, so 5x minus 5 is equal to 0. And then I cover that up. What minus 5 is 0? 5 minus 5 is 0, so that means 5x is equal to 5. 5 times what is 5? And that would be 1. So 1 is our second anchor. All right, we go back up here. We have a less than symbol, so we know that's going to be an open circle. All right, so I'm going to have an open circle on 1. Okay, now I have to test and see which way to shade. So we're going to test 0 again. So I'm going to have 6 times 0 minus 8 is less than 0 minus 3. All right, so 6 times 0 is 0, so I get negative 8 is less than negative 3, which is a true statement. All right, so 0's on the left, so I want to shade to the left. And there I go. Now, once again, we can see that we get that crossover region, which is that solution, and both things have to be true. So we can see that -2 is our left endpoint, 1 is our right endpoint. We want those numbers in between. So x has to be greater than -2, and x has to be less than 1. All right, my friends, there's your introduction to solving and compound inequalities. All right, so be sure to do your video check-in, and we're going to wrap up our unit on inequalities with our next lesson. Have a good night, and I'll see you next time.